A wire that is lying along the x-axis that carries a current of 30 amps in the plus x direction. A proton at r equals 2.5 J has instantaneous velocity v equals 2 in the I hat minus 3 in the J hat plus 4 in the K hat, where r is in meters and b is in meters per second. What is the instantaneous magnetic force on this proton? So I have a force that I have to calculate on this proton moving in a magnetic field. The force on something moving in a magnetic field is Q times V cross B. So we have to do a cross product. We have to remember cross products from earlier this semester and last semester. None of this ever goes away. I'm going to continue to need this. Is that okay?
Until we graduate.
Yeah. Until you graduate. And then in med school, you'll Oh, that's so mean. That's so mean.
No way, I mean.
So you should, let me read. So we need to be able to take cross products, and we need to identify a bunch of things. So let's draw a picture of what's going on. We have a x and y axis. And we have a wire lying along this x-axis. So here's my wire. And it's carrying a current that's going entirely in the x direction. So my current is going entirely in the x. Okay. So then we also have a particle that's moving. And this proton is at a position 2.5 J hat. How do I draw that? What does that mean? 2.5 J hat. So that means it's at the position 2.5 in the J hat direction. So I go to 0. I don't move over left or right on the x-axis at all. I just move up 2.5. So I'm up here on the J-axis. Okay. So that's where my proton is. Let's draw my proton in blue. And it's moving with a specific velocity. Let's see, what's the velocity of this thing? Is 2 in the I hat, minus 3 in the J hat, plus 4 in the K hat. Not going to try to draw that. That would be drawing in 3 dimensions, and that's a pain in the butt. So what kind of information do I need in order to calculate the answer to this question, in order to find the force? So look at your force equation. What variables do you have? If I want to calculate the force, what variables are involved in this? Just read out the variables. I've given you the equation. Q, V, and B. Do I know what Q is? What is Q? .6 times 10 to the negative 19. How do we know that? It's the charge of a proton. Okay. What else do I need? I need V, and I have V, and I need B. Was I given B? No. Is there a magnetic field drawn in there? No. Is there an actual magnetic field? Yeah? Why? I don't see one. Where does the magnetic field come from? Current. Current in a long straight wire creates a magnetic field. This is one of the right-hand rules that we need to know. Okay. Current current in a wire creates a magnetic field. B, due to a long straight wire, is mu naught times I divided by 2 times pi times the radius, times the distance you are from that current, from that wire. To figure out the direction that it's going, I take my right hand. This is the second what I call the second right hand rule. My thumb goes in the direction that the current's going. I bend my fingers 90 degrees, and that shows me the direction of the magnetic field. Take my thumb, point in the direction of the current, point my fingers to where I want the magnetic field, and then bend them to get the direction of the magnetic field. And this will all work for a positive charge. We'll talk about how to do a negative charge. So I take my thumb, I point in the direction of I. I is going this way. Do I want the magnetic field above the wire or below the wire? Do I want the magnetic field up here or down here? up here. Why do I want the magnetic field up here? Because that's where my charge is. So take my thumb, point in the direction of the current. My fingers, I want the magnetic field up above the wire, and when I bend them, what direction are my fingers going? Z. They're coming out of the board. So what is Z in terms of unit vectors? So that's in the k-hat direction. Okay, so I get that from the second right-hand rule. If I was underneath the wire, if my point was down here, then I would have my hand. I can't elevate my hand anymore. Yes, I can. Watch this. Yeah, I'm high. So I point my thumb in the direction of the current. I'm now below the wire. If I want down here, I bend my fingers. What direction are my fingers going now? They're going into the board, so the magnetic field down here is going into the board. Okay? What if this was a negative charge? What would change? For a negative charge, anything you get with the right-hand rule, you just reverse. So if this is negative, here's my thumb going to the left. I want the magnetic field up here. Bend my fingers, they're pointing out of the board. So that works for a positive charge. Magnetic field on the negative charge would be going into the board. Okay? Alrighty. So now I can calculate this magnetic field. B is equal to mu naught, which is 4 pi times 10 to the negative 7. That's a constant, times the current. What is the current that we have running through this? I think they gave us is 30 amps. Divided by 2 times pi times R, where R is 2.5 J hat. And that's going to be in the K hat direction. So my magnetic field, when I plug and chug all these things in, is 2.4 times 10 to the negative 6 Tesla in the K hat direction. So now I can find my F. I can find the magnitude of F by just plugging in all these variables. F equals Q times V cross B. The way I like to do cross products, what helps me, is I take all the variables and I multiply all the variables together, all the numbers, and then I take the directions and I put those as their separate cross products. So we'll see what I mean. So I have Q times V. I'm going to go ahead and calculate that right away. So I do that 1.6 times 10 to the negative 19, and I multiply that by 2 in the I hat, minus 3 in the J hat, plus 4 in the K hat. So this gives me QV is 3.2 times 10 to the negative 19 in the I hat. So we get what I did there? 1.6 times 10 to the negative 19 is the Q, and I'm multiplying it by each one of these parts of the V. 1.6 times 2 is 3.2 in the I hat. 1.6 times 10 to the negative 19 times negative 3 is going to give me negative 4.8 times 10 to the negative 19 in the J hat. Plus 4 times 1.6 times 10 to the negative 19 gives me 6.4 times 10 to the negative 19 in the K hat. So that gives me this Q times V. Then I need to cross that into B. So my B is 2.4 times 10 to the negative 6 Tesla in the K hat. So I need to take this cross product, Q times V crossed into B. So 3.2 times 10 to the negative 19 in the I hat, minus 4.8 times 10 to the negative 19 J hat, plus 6.4 times 10 to the negative 19 K hat,
cross 2.4 times 10 to the negative 6 in the k hat. I think so. I hope so.
Me too.
So now, when I'm doing this cross product, I take the numbers and I multiply the numbers together, and then I have the i's cross into k, j cross k, k cross k. So I distribute, basically, use the distributive property.
So to do that, we get 3.2 times 10 to the negative 19 times 2.4 times 10 to the negative 6. And we do I hat cross k hat. And then we distribute the next part. Plus a negative 4.8 times 10 to the negative 19 times 2.4 times 10 to the negative 6. And then we do j cross k. Plus 6.4 times 10 to the negative 19 times 2.4 times 10 to the negative 6, k cross k.
Do you have any questions on what we've done so far? Now I have to take these cross products. What is I cross k?
Oh, we have to draw it that. Oh yeah. Can we
So
draw
this
the
is,
chart?
you can draw the chart or you can do the right-hand rule. We'll do the right-hand rule, then we'll draw the chart. So if I do the right-hand rule, my fingers go in the direction of I. So that's I direction. I rotate my arm around so I can bend my fingers in the direction of K. So to do that, I need to rotate my hand around upside down. I bend my fingers, they go in the direction of K. That gets my thumb going down, so that should be the negative J direction.
Okay. So I can multiply all these numbers out, and I get 3.2 times 2.4. That gives me 7.7 times 10 to the negative 25 in the negative j hat direction. And then I multiply my other two numbers, my 4.8 times 2.4. That gives me 1.15 times 10 to the negative 24. There's a negative out front of that.
And then I do J cross K. So J, I've got to have my fingers pointing up. Crossed into K, I bend my fingers so that they come out of the board. My thumb is pointing over to the right, so that's positive I hat. And then K cross K. What is K cross K? 0.
So that goes away. Cross product of parallel vectors is 0.
So how do we do this with a chart?
We have the I, J, K, I, J, K. Or if we go backwards, then we have negatives. K, J, I, K, J, I. I look at my I cross K. I cross K. If I look at this top chart, I go from I, the next variable is J, so there's no way I can go from I to K. So I go to the bottom one, I can go from I to K, and that gets me to J, and since I use the bottom one, I get a negative J. And then I have J cross K, J, next comes K, after that we get I, since it's the top one, that's a positive I hat. So there's my final answer. That's my force.
Physics one coming to bite us in the ass. Okay?
Crazy. So on problem number 9,
we've got a proton that's moving through a vertical magnetic field. The instantaneous velocity of the proton is 8 times 10 to the 5 meters per second, horizontally in the north direction. No idea what the hell that means. And the instantaneous acceleration produced by the magnetic force is 3.2 times 10 to the 14 meters per second squared in the west direction. What is the magnitude of the magnetic field? And is the direction of this field up or down? Okay, what the heck is this thing talking about? So I think the hard part of this problem isn't so much the problem itself, it's identifying what they mean by traveling horizontally north. And what does west mean? What do all these directions mean? So getting a picture of this is the difficult part. So first we know that it's a magnetic field that's going vertically. They tell us a vertical magnetic field. So our magnetic field has to either be going up or down. That's the magnetic field. I don't know which direction it's actually going. I just know it's going either up or down. We are asked to find the magnetic field of a proton that's moving inside of this. So we have a proton moving in a magnetic field. That means we've got a force acting on it. That force is Q times V crossed into B. So the variables I need to know F, I need to know Q, I need to know V, I need to know B. Do I know any of these? Did they give us the force? Did they give us a force?
No.
No, okay. What else did they give us? They gave us a velocity. So I have velocity, right? I can write down the velocity of this proton is 8 times 10 to the 5th meters per second. And they tell us that it's going that way horizontally in the north direction. What the heck does that mean?
It's going up.
Well, this is up.
Oh, that's down.
That's vertically. Going out. So when they say north direction means K hat. On an exam, I would tell you it's going in the K hat direction. Okay? So we know that this is going in the K hat direction. V is in the K hat. Yep. They tell us the instantaneous acceleration produced by the magnetic force is 3.2 times 10 to the 14 meters per second squared in the west direction. So they gave us an acceleration. No idea why they gave us that, but they gave us that it's 3.2 times 10 to the 14 meters per second squared. That's got to have a direction. It's going in the west direction. What is west? I have vertical is up and down. That's J. I have north is I. So what would south be? Well, I have north is K, sorry. So south would be negative K. So east and west are I and negative I. So if I'm going in the west direction, I'm going in the negative I hat direction. Okay, what other variables do I need? I need to know what Q is. Do I know what Q is? I do. What is it? Negative 19 coulombs, because it's a proton. So I know that. I'm asked to find the magnetic field. Which variable is that? Which one of these am I actually looking for? F, Q, V, or B? Well, I was given B. I have Q. So I need to find F or B. B. Why? That's the magnetic field. So I need to find what B is. This is everything I was given. Am I missing stuff? What variable do I need? I need F. We all need F's. I'm sure we'll have plenty of F's once I look at your exam.
Yeah.
F? F equals MA. F equals mass times the acceleration. So I can take that acceleration that they gave us and I can multiply it by the mass. Do I know the mass? What is the mass? 1.67 times 10 to the negative 27. 1.67 times 10 to the negative 27. How did Mumbles in the back know that?
Textbook.
It's in the book. Okay? That is the mass of a proton. If I gave you that this is an electron moving in this field, what would you have to do? Use the mass of an electron. Would we have to change the charge?
Can you repeat the question?
If I gave you an electron instead of a proton,
Oh.
I have to use a different mass.
The charge
Yeah,
is
it would be negative.
Charge would be negative, so I have to use a negative 1.6 because the electron is. Okay. Okay, so I can calculate what this F is. The force is mass times acceleration, so I can calculate what that is. And then I can find the magnitude of B. B is the mass times the acceleration, which is the force, divided by Q times V. So I plug and chug all my numbers in. Mass is 1.67 times 10 to the negative 27. Acceleration is 3.2 times 10 to the 14. Divided by Q is 1.6 times 10 to the negative 19. V is 8 times 10 to the 5th. Plug and chuck all those numbers in, and I get that my B is 4.18 Tesla. But that's just the magnitude of B. I'm still missing something. Okay. I'm missing direction. So I know some directions. I know that my velocity is coming out. So this is my V. What do I know about force?
It equals mass times gravity.
It does. And what direction is it going?
Up.
It was going west. The force was going west. Force is going in the negative I hat. So I got my force going over this way. And I need to figure out if my magnetic field is going either up or down. So I got to use the right-hand rule again. My fingers go in the direction of V. I bend them in the direction of B, and that gives me the direction of the force. B is coming out. I bend my fingers in the direction of B. What direction is B going? We don't know what direction B is going. We know what direction F is going. That's crazy. We've never had that before. How do I do this?
Ask Dr. Bubar.
Well, Dr. Bubar doesn't know. I spent all morning picking out my wonderful mustard sweater. Last Monday I was ketchup, not mustard. I should get a green one.
Relish?
Guacamole.
Oh.
A white one.
Mayonnaise?
Mayonnaise. I can ask you questions about condiments and you're all answering. I ask you physics questions and I get
Of
nothing.
course. We like food, not physics.
What is the best condiment?
I like honey mustard.
Huh?
Honey mustard.
Honey mustard.
Sriracha?
Honey mustard.
Well,
Yeah.
guacamole is not a condiment.
Peanut butter's a condiment.
It is.
Oh my gosh, almond butter then.
Nutella.
Nutella.
Oh, you win.
Okay, I won physics. Okay, well how do I do this? We've never done this before. We always have our fingers and then we bend them in the direction of B and we got our thumb in the direction that it's supposed to be. So
You point your thumb towards the force.
I need my thumb towards the force. Okay, what direction is the force going? Force is going that way. My fingers need to go in the direction of V, don't they? So what direction do my fingers need to be going? Out towards this. So I need to rotate my hand around so that my fingers are coming towards this. And then what direction do my fingers bend? I bend my fingers are going up. So that means the magnetic field has to be going up. So that's the J hat direction. I can. So I know that my fingers go in the direction of V, I bend them in the direction of B, and my thumb goes in the direction of force. Normally we're given V and B to find the thumb. Here I'm given V and F. So I can take my thumb and I can point it in the direction that F needs to be. So I do that. And then I need to rotate my hand around so that my fingers are pointing in whatever direction V is going. V is coming out of the board, so I need to rotate my hand around so it's coming out of the board. And then the only way I can bend my fingers is up to get my direction of V. Okay. Any questions? Okay, so that's problem number 9. So in problem number 35, I have a wire that's been bent. So here's a wire. It's been bent into a loop. It keeps going. And I have some current that's going through this wire. Current comes here, hits this little kink where I bent it, and it starts moving around the loop, and then it keeps going. So that's the direction of my current. Thank you very much. Okay, how do I do this? So the question actually asks us to find what is the magnetic field produced by these wires at the exact middle of this circle. And I can treat this like I have 2 different wires in this problem. I have a long straight wire, that's the horizontal one. That's going to create a magnetic field. And then I also have this loop. This loop is going to create a magnetic field as well. So I have 2 magnetic fields that I'm getting out of this. I have the magnetic field due to the wire, and that's mu naught times I divided by 2 times pi times r, where the radius of this loop is r. And I can see that because if I draw my radius, I am a distance r away from that wire. I'm missing the direction. I need to know what direction that's going. And then I have B of the loop. Magnetic field of a loop is mu naught times I divided by 2 times just plain r, no pi. So that loop creates its own magnetic field, also going in a specific direction. To do this, I need to use that second right-hand rule. I have current, and I want to know where B is going. This is where you use your thumb in the direction of current, point your fingers to where you want the B field, and then bend them, and that gives you where the B field is going. So in this one, what direction does my thumb go for the wire? Let's figure out the wire first. What direction is my wire going? Is my current going to the right or to the left?
Right.
It's going to the right, so I put my thumb to the right. Do I want the magnetic field up above the wire or below the wire? Above. So I point my fingers up above. I bend my fingers. What direction are they going? Out of the board in the z direction, so that would be in the k hat. So this is no longer unknown. We now know that this is going in the k hat direction. It's the magnetic field from the wire. Now the magnetic field from the loop. I need to pick a position on this loop. I can pick anywhere. Where do you want to go? Do you want to go on the left side of the loop, right side of the loop, or top of the loop? Left side of the loop? Okay, so I take my thumb and I put it in the direction that the current is going along this left side of the wire. What direction is the current going? It's going up or down? It's going up. Do I want the magnetic field that's on the right side or on the left side? Do I want it inside the loop over here or outside the loop? I want the magnetic field right there at the middle. So is that to the right of my thumb or to the left of my thumb? To the right of my thumb. So my fingers point this way. I bend my fingers. What direction are they going? They're going into the board. So what direction does the magnetic field from the loop go? That's got to go into the board. So that's got to be the negative k hat. Wait a second. I'm not convinced that's right. Okay. Let's go to the right side of the wire.
Sure.
Yeah, the right side should give the right answer. The left side gives the left answer. The right side. So we go to the right side. What direction is my current going around this loop on the right side of the wire? It's going down. Like all your grades.
Oh.
We're going down. On the left side. Do I want, on the right side of the wire, do I want to know the magnetic field towards the left or towards the right? Towards the left, so I point my fingers left. I bend my fingers. What direction are they going? In. Still into the board? I'm still not convinced. Where else can I go? I can go to the top. So on the top, am I going to the left or to the right? I'm going to the right. So I got to be taller. I want to be underneath. So I take my hand and I give myself carpal tunnel.
Because I bend my thumb, bend my fingers, and they're going into the board. How about at the bottom? Right down here. So right when the current first starts going, over on this side, it's going to the right. Bend my finger, it's going into the board. Okay. So that magnetic field is going into the board.
So the total magnetic field is equal to mu naught I over 2 pi r minus mu naught I over 2r in the k hat direction. Technically, this would be a correct answer to this problem.
If I were to give this on an exam, I would ask very specifically exactly what direction is the magnetic field going. Here you've just told me it's going into k hat. You haven't specified that you know that it's going either positive or negative k hat. So I would ask you, specify, is it positive or is it negative k hat? Can we figure that out? Yeah. Why the wire is in the k hat? Absolutely. So in the wire, I imagine that the current's going to the right, through this whole wire. And the loop is above the wire, so I take my thumb, point it to the right. I take my fingers, I'm above the wire. I bend my fingers, they point out, so it's a k hat. Yeah? So if I ask you specifically, is it in the positive k hat or negative k hat? Which direction does this go? That question is basically which one of these is bigger. So is the magnetic field of the wire bigger or from the loop bigger? Talk about it at your tables. Talk. Speak.
So it makes the whole. Sounds good to me. She has a good reason.
Yeah. The math major has a good answer?
I believe it because she used math.
Shocking.
So she started throwing in denominators like she knows.
Can you explain again why it's 2R on the bottom instead of 2 pi?
That is the equation for magnetic field in the loop.
Oh,
They derive it in the book.
okay.
If you look in the chapter summary, they flat out just give you that equation.
Okay.
That's why I always recommend note cards and memorize those things. You don't actually learn anything, but it makes your life easier. Okay. Yeah. Magnetic field from a loop, this is the definition of what it is. If you look in the book, they derive this for you. But this is one of those equations in the chapter summary that I tell you, no cards, just flat out memorize. Yeah. And this works for the center of this loop. It's only one very specific location. So, which one's bigger? Wire or loop? Loop?
Yeah.
What do we say? Loop? 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 Why loop?
Because
But two reasons.
it's lower.
Leah just said wire, so we know that's not the right answer. That's being recorded too. So, but why else? Why do we know the loop is bigger?
Because the denominator is smaller.
Denominator is smaller because you have a pi in here that makes that denominator bigger, so that makes your wire smaller. Math. Yay, math. Any questions on number 35?
No.
It would be the negative k hat. If you write it this way, that doesn't show me that you realize that. This will be bigger, so it will turn out to be negative, but it doesn't demonstrate that you actually realize that. I could change the question and just ask you what direction it's going, and not even ask you for the magnitude. You'd still follow the same procedure, but